focusing on the Chrome Apps API, which contains a lot of security concerns in the thing. And currently I'm focusing on web security, source code analysis, and algorithm and stuff.
And I'm Sergey Shekyan. I'm engineer at Shape as well. I work mainly on web security stuff. And prior to that, I was working at Qualys for 4 years, developing their web application vulnerability scanner engine. And yeah, that's about ourselves. So just to introduce you what headless browser is, imagine a Chrome with developer tools enabled without the actual Chrome UI, but with JavaScript API to that developer tools. So headless browsers can be grouped into 3 categories. So first category would be some tools that have a real web browser engine backing them. Those are like Phantom.js that has a WebKit engine, or Slimer.js, which is similar to Phantom.js and even has the same API, JavaScript API, but it's backed with Gecko. And Trifle.js is an attempt to automate a Trident engine, which is IE's heart. And another category would be something that looks like a browser from a programming point of view, but it's not really a browser. It doesn't have a real browser engine in it. And Zombie.js or HTML unit Zombie.js is Node.js-based custom JavaScript engine which mimics a browser, and HTML unit is Java-based. And third group would be to actually drive actual browsers that support WebDriver API, and like all major browsers do support, with Selenium server. So you can control a remote browser or like local browser with Selenium script written on it, Selenium script that's loaded into Selenium server. And yeah, that's another way to control the browser. But our talk is going to be mostly focused on Phantom.js, mainly because of the reasons listed on the slides. And another reason, author of Phantom.js works with us, so we have a little bit advantage. We have some insider knowledge on the top of all these facts. Bay will introduce the basic architecture of how Phantom.js works and an example.
Yeah. So this is how Phantom.js works. In Phantom.js, there are 2 different kinds of JavaScript contexts. Because Phantom.js is driven by JavaScript, so it will have a Phantom.js JavaScript engine context directly initiated by Phantom.js. And from that context, you can generate different pages, a series of pages, and each page will be a Q web frame, which is part of Qt WebKit widget. And inside the Q web frame, there is a Qt WebKit engine, and also there is a WebKit. There's a web page JavaScript context. Then from the Phantom.js JavaScript engine context, you can control the page, and you can listen to the events sent from the WebKit engine. And you can also inject your JavaScript code directly into the JavaScript context inside the page. And you can also, from the page, calling some functions, not really functions, but there's a mechanism to actually call back from the web page into the Phantom.js. So a simple code to use Phantom.js will look like this. So this is something look like the Node.js, the required. Then you require the module web page. Then you call create on it. You will create a page that is running WebKit inside it. Then you open a URL on the page. After the page is opened, then you can is there a pointer?
No.
So then you can actually evaluate some functions on the page. Note that the page.evaluate will actually serialize the given function into a string and send it into the page, and evaluate the string as a function, then send back the result, which is also serialized. Yep. So Phantom.js is very popular for functional and performance testing among web developers. And you can also use PhantomJS to crawl a page that, for example, if the page has some dynamic contents down them, you have to actually run the JavaScript on the page before you can actually review the topology of the website. It's also used for SEO when before Google actually have the ability to run JavaScript in their crawler, because you can actually run PhantomJS and render it into a static HTML file and feed it into, for the crawlers. And it also can be used for reporting, image generation, website archivement, and a lot of different things.
And PhantomJS has at least 8 million downloads, so that's why we say it's quite popular.
Yes. Yeah, it's 7.9 million downloads so far. And PhantomJS can be used maliciously as well. You see, you can run a PhantomJS and fuzz a page to find the vulnerable parts of the web page. You can deploy it on a bot network. In fact, last year there is a report on a DDoS attack, which is using about 180,000 IPs running PhantomJS, and they are actually simulating different user agents, about 700 different user agents. And you can use PhantomJS for content scraping, login brute force attacks, click fraud, credential stuffing, bidding wars, and different ways. So web administrators tend to actually block PhantomJS in production. So if you're using PhantomJS for malicious use or not, well, you will want to actually cover your track, like you want to actually do this. Pretend you are somebody else. Okay, from this point, me and Sergey will play on the two parts. I will play the PhantomJS, and he will play the website. I will try to spoof my user agent, and he will try to detect whether I'm PhantomJS or not. Okay.
Yeah. So initially we wanted to have black hat and white hat, and just pretend we are, but we didn't find hats here in Denver, or suitable hats. So yeah, I will be the guy with that strange accent who, for some reason, pretends to be the good guy and to detect PhantomJS visitors on my website and try to do something about it.
And I will be the, sorry. Wait, hello? Hello?
Speak here.
Hello? Sorry.
Yeah, and they will be the bad guy.
And I will be the, I will be the Chinese accented bad guy with horrible grammar there. Yeah.
Okay, so just another sort of introduction. So yeah, we know that PhantomJS is running WebKit engine with real JavaScript core and with real web core, real CSS stuff, but there must be something different from real browser. And here are the differences listed. Basically, WebKit itself doesn't implement, for example, network stack or cookie jar or the actual image generation. So somebody should do that for Phantom, and Phantom is based on Qt framework, and actually the Qt WebKit wrapper around WebKit. So Phantom is basically using Qt frameworks, network stack, and cookie jar, and lots of other stuff, like font generation, font handling. And yeah, that would be the difference pretty much between Phantom and the real browser, and we'll try to catch those differences. Yeah, another major thing that Phantom, by the way, introduces, it adds two properties to the window of your JavaScript environment. Window call Phantom and window underscore Phantom, but we'll come back to that later. And yeah, as a good guy, what can I do? The simplest thing is to start looking at the user agent, right? Since we know that all versions of PhantomJS come with default value of user agent string that will always contain PhantomJS, so we'll just look for it. If guy says, I'm PhantomJS, why shouldn't I believe him? And what are you going to do about it, babe?
So yeah, what I'm going to do? Yeah, user agent string. It's actually the first or the easiest thing to spoof, actually. So PhantomJS actually provided you a API to spoof it. You can say page the setting, the user agent equals to this one is Firefox. Then inside the HTTP header, the request being sent, and the page window.navigate.userAgent will be the user agent string will be replaced with this. Yeah, that's all. Thank you. No, we're too busy like smoking pots and stuff. No, psych. Okay, so scoreboard. User agent string inspection. This time Phantom will win. Sergey?
Yeah, another thing to look at is, for example, plugins, right? Like we know that majority of browsers there in the wild would have some kind of plugin handlers that handle content with MIME type that's not natively supported by the browser. And Phantom.js shouldn't have any because there's no no default way to provide Phantom.js with plugin handlers. So why wouldn't I check through JavaScript API what plugin array looks like? And if it's empty, then probably it's Phantom.js. Like there are not too many people who are disabling all the plugins in their browsers. So that's a pretty good indicator. What are you gonna do?
Yeah, it turns out to be a kind of hard question. First of all, if you want to actually have some plugins in Phantom.js, it's basically impossible. You're gonna change a lot of C++ code to do that. And so you would try to actually spoof the navigator, the plugins object there. And the second problem is that navigator inside Phantom.js is a read-only object, and the navigator.plugins is also a read-only object. You cannot actually just change the length of it. And so this is what we do. We actually create new objects and set the thing we want to change, like the plugins.length equals 1. Then we say that we change the prototype of the object to the prototype of the original object. Then when you say whether navigator instance of navigator, you know what I'm saying, right? So that will actually pass the test of his test. It's the same thing for navigator. So you want to change the navigator object by creating a new object and setting the prototype to the original one. Also, you may want to copy all the own properties from navigators and the plugins back to the new objects. So the object that has own property will, the navigator that has own property will act exactly the same as the original navigator. But there's a third problem, that since you cannot actually create a plugin, then if the website sends you a flash and require you to run it, you will basically no way to run it. So the conclusion will be it's not really a good ideal way to spoof this kind of things. So scoreboard. Second one, Phantom.js loses and the website wins. Sergey.
Okay, so there is, there is another knowledge that we gain from Phantom. We know that Phantom.js is going to suppress any kind of JavaScript-generated dialogues like alert or prompt or the confirm dialog or whatever, and which means whenever you pop an alert on the page, it's going to return immediately. So we can just start measuring it, right? And code like that would just measure the difference between creating the actual alert and when was it clicked back. And if it's something like less than 15 milliseconds, then probably it's a bot or Phantom.js or just another bot in general. So looks like it's like hard problem for circumvent for you.
As we mentioned before, Phantom.js has only one JavaScript engine, but have different JavaScript contexts. So when you say prompt there, it's waiting for you to have an immediate return from some other parts of the JavaScript engine. So you cannot actually do that asynchronously, meaning that if you really want to wait like more than 50 milliseconds inside prompt, you will have to wait it synchronously, which means you have to like run an empty loop for like 10 million times and then you return. This is the callback from Phantom.js for all the alert that's issued from inside the page. And this is horrible because, well, your Phantom.js can be doxed by the website. And so this time, the scoreboard will show that Phantom.js loses and the website wins. Okay.
Yeah, another thing to look at is, since I mentioned that one of the major differences between Phantom and the real browser, that network stack is actually implemented by Qt framework. So we noticed that there are like obvious differences. And for example, HTTP headers, we noticed that all modern browsers will put host header on top of the list, while Phantom wouldn't, no matter which version of Phantom.js. And also, for example, keep alive or some other header values would be camel cased in Phantom.js and not in real browsers. Almost all real browsers except Opera 12, which was pre-Blink version of Opera. And now Opera is using the same engine as Chrome. So yeah, it's pretty reliable way to catch Phantom, right?
Yes, it is. In fact, the reason that host is at last in Phantom.js is because Qt Network Manager will actually initialize the request in a certain order. So the order in here actually reflects the order that the Q Network Manager actually generates the request. And it's really hard to actually spoof it. And if you want to spoof it, you have to change a lot of code inside Qt framework, which may not worth it. So actually there is an easy spoof that you put a custom proxy in front of Phantom.js. And that proxy, inside that proxy, you can actually change the order of the headers. And also as like if you want to spoof Firefox, then you change the header to Firefox. If you want to spoof Chrome, you change the header to Chrome. And you can use that for the lowercase stuff as well. So this time, the result will be Phantom wins. It's okay.
Yeah, as I mentioned, Phantom is adding these two properties to the window object of the web page's JavaScript context. So why wouldn't I just check for presence of those properties? And that's kind of clear indication that my JavaScript is running in Phantom.js JavaScript context, right?
Mm-hmm. Yeah, this one is like, this is the new functionality Phantom provided to the web page. The API here is can be called inside a web page instead of the Phantom.js script. So if you want to actually spoof it, it will be easy. Just delete them, right? You just delete window the call Phantom in the beginning of when the page is loaded. Then this code, which is embedded inside the page, will not actually detect whether it's Phantom.js, whether it's Phantom.js. But a lot of cases, you still want to send callbacks from the page to Phantom.js. So you cannot just delete it. A solution here will be you save it somewhere else and define a property on window or whatever thing you can rely on. Then the property name will be something the page cannot guess. And then set the property to be not enumerable. Enumerable : false. Therefore, the script inside the page cannot like into a window to test whether there is like fishy properties in there. So with that, probably you just can't find whether there's a call Phantom call there. So this time, Phantom.js wins. This 5 were 1, 2, 3. Yeah, Sergey.
Yeah, so we know the JavaScript engine of Phantom.js and like WebKit are old. So there is pretty high probability that HTML5, not all of HTML5 APIs are implemented. We didn't actually create any examples because it's sort of straightforward how to implement a test to see if the actual HTML5 API is implemented. Like web audio, if you don't have access to the actual mic or speaker, maybe it'd be hard to figure out. Maybe it'd be easy to figure out that's a spoofed one. Or like WebSockets are are not RFC compliant implementation, is not a RFC compliant implementation, and you can guess the difference from the WebSocket handshake, for example.
Yeah, I guess I will just give up this time. It's too hard to spoof. So yeah.
Yeah, so checking for HTML5 features is probably gonna work for the from the detection side. So website wins. Yeah, another major difference between JavaScript engine in Phantom.js and real browsers that it doesn't support function prototype bind, and a lot of third-party JavaScript libraries actually rely on the existence of that bind, like jQuery and AngularJS, or simply wouldn't work in older versions of Phantom. And that's the major or most popular topic on Phantom.js related websites. Like, dude, when are you going to implement bind? My jQuery doesn't work, or like it doesn't work properly for all the cases. And yeah, the good solution is to just spoof bind, or like implement something that would look like bind, function prototype bind. And yeah, Bay can get into more details.
So the code you're looking at is the first of all, let me explain what is a function, the prototype, the bind. It's a function that is defined on a function that when you call function, some function dot bind will take the first argument of the call as this pointer, or sometimes you call scope, of the function it returns. Say if you have a function that simply returns this, then you call this function dot bind with some other thing, for example, bind with document. Then when you call the function that's returned by bind, it will actually return document to you. So this is basically, okay, so, this is basically what it does. Take the function as this pointer and the self as the first argument, and then inside the return function, you call func.apply with the self and some other details. Okay. So one easy way to detect this is to say, okay, I would try to say that whether function the prototype that bind the toString result is actually a native function. So you can distinguish a native function and a spoof function by calling the function .toString. And then if you actually defining the function inside the JavaScript, the toString will actually give you the source code of the function. But if you're defining the function in a native way, then the content of the function will be a bracket native object or something.
Native code.
Yeah, native code, something like that. So by doing this, you can actually test whether bind is created, spoofed or not. But this leaves a question that, hey, toString is also a function, then we can actually spoof toString, right? So it will look like this. If this is bind, then we'll return a native string that looks like bind. Otherwise, we just call the original toString. Well, you're spoofing toString, meaning that to detect that, you can call toString.toString to test it. Like this. So function the prototype the toString, call that and test that whether it's native code. Yeah, I have a question. Is it gonna work? Everyone know, is this gonna work? Say, if I say toString.toString equals toString, okay, function the prototype.toString equals to function the prototype.toString, then you can spoof it, right? No, not really, because the detector can delete function the prototype.toString, and the original toString will be reviewed. So we have to go back to the toString code and actually make a separate case of toString itself, like this. The original one is this equals to bind, then you return a native string. Now we have to say if also that is toString, then you return a native string as well. Then somewhere else we will call and apply and a function. For them, you have to do that as well. Another observation is that the function returned by bind is also a native function. So whenever you bind any function, then you should put the new function inside the list and test whether the list contains the function you want to spoof. And if that's the case, then you return a native string there. Now, this is a hard trick. And so far, we haven't found any way to detect this spoofing. So this time, weirdly enough, PhantomJS wins. It's okay.
Yeah. So, but there is PhantomJS 2 coming. Will be released pretty soon. It's not release date is not defined, but develop branch on their GitHub repository contains working PhantomJS 2, which has actually pretty up-to-date WebKit engine. It's like from January this year, but from now on it will be really easy to update WebKit that's running behind PhantomJS to like whatever the nightly build is. So it's going to be pretty fresh. And on the other hand, it's very bad news. It's pretty good news for Bay because from now on it won't be possible to look at JavaScript engine differences and like make any kind of observations based on that because there is a ECMA 5 test suite called Test 262, and PhantomJS actually fails. It's like 500 or 600 tests, or even more. I don't know. It fails only 2 tests, and those are exactly the same tests that fail Safari 7, for example. So by looking at JavaScript engine, it won't be really possible to tell the environment your script is running in. And
so we have to move to something that's
which means we need to move to something that's different from the actual like JavaScript engine properties. But we're not moving too far. It's still produced by JavaScript. So we know that looking at call phantom is unreliable, but let's look at the stack trace. So I tried to run a code that throws an error, and from error object in any browser, although it's not a standard feature, but any error object would contain the stack trace of the place in the code where the actual error was thrown. And we ran that code in PhantomJS and in Slimer.js, which is Gecko-based headless browser. And like stack traces are completely different, but there's one common thing. They both contain PhantomJS : //. And let's try to do something with that. So we not figured out, but it's sort of natural. So everything can be spoofed in JavaScript. As in Bay's bind example, you can see that JavaScript is a horrible language, and yeah, pretty much everything can be spoofed. But we know some fact which can help us. So if you make JavaScript engine to throw an error, it's not like your code is throwing an error, but you're making JavaScript engine to throw an error, then non-modified error object will be thrown. We'll get to that catch state, catch clause. And by that, we can look at that errors stack later and see if it contains PhantomJS, then probably it's either Phantom or Slimer or any other like PhantomJS-based user agent. And yeah, it turns out that it's quite difficult to spoof the stack trace.
Yes.
What can we do?
So stack trace, first of all, stack trace is not part of the ECMAScript spec. So every browser has its own way to like format the stack. Like different browsers will have a different way to format the stack. So at least that part, the PhantomJS part, can be removed because the string have to show up somewhere in the source code. So we grab the source code and find this. So that piece of code is the part that PhantomJS : / is injected inside the call stack. Then we remove that code, we get the stack trace like that. At empty. Well, this is not very nicely looking because it still is quite different from any other browsers like this. So we added some other things inside the PhantomJS, and we try to spoof Chrome. Inside Chrome, if you use DevTools, the object, the injected script, will be showing up in the stack trace if you're actually initiating a function from the developed tools. So we added that part, and it's still looks really different from the original one. So this is actually a very good fingerprinting way, fingerprinting technique for Phantom.js.
And not only Phantom, but for like any browser. Like if you know
Yes,
how
yeah.
Google Chrome stack trace would look like, or like the structure of the stack trace, then you can probably always write pretty complicated regular expression that would tell you if it's like real Google Chrome stack trace or not.
So the scoreboard.
And there's another observation. As you can notice that Phantom.js is putting, on the last line, it puts a full absolute path to the file, which is the actual Phantom.js script. So we will use that knowledge later.
Yeah. So the scoreboard will be, this time, Phantom.js will definitely lose. We actually have other ways to fingerprint, actually many other ways to fingerprint a browser. Like, since you know Phantom.js is using Qt graphics engine to render all the page, then you can actually do a canvas fingerprinting, just like draw some random elements on them and get the data from the canvas, and then hash the data. Some techniques like that will perfectly detect Phantom.js. So now there are other ways to actually spoof them, but for now we have a score 4-4. Yeah. So, sorry.
It's actually, yeah, supposed to look like this. So yeah, we went through many different ways of detecting Phantom.js, and that will lead us to a natural question. What can we do once we caught malicious Phantom.js or unwanted Phantom.js in the
Before
wild?
sliding, anyone know what that is? This is
Even I don't know.
okay. Yeah, I think it's sorry.
Some kind of movie or?
It's a comic called Attack on Titans, and that is a Titan. Yeah,
Okay.
Okay. Anyway.
Yeah, so what can be done once you figured out that a user agent that visits your website is unwanted Phantom.js instance? So because of these reasons, since like normally most of the people are running Phantom.js as the same user as their like shell, it can be pretty dangerous. Or we know there's no sandboxing, and Phantom.js is running, all the pages that you open in Phantom.js will run in the same process space. Not like in the browsers when every tab has its own process space. And like Qt itself has a lot of outdated, like you can search for Qt vulnerabilities and you'll see a lot of reports on either using outdated libpng or libxml or font handler or I don't know, GIF parser. A lot of attack vectors can be found on that layer as well. So it can possibly lead to either abusing the Phantom.js process itself, or if you are lucky, maybe the operating system that runs Phantom.js. So first example, it's based on that stack trace technique, looking at the stack trace of thrown by JavaScript engine error. It's just a sample example, but you can extend it as much as you want. So we picked some the first trick is to make Phantom.js execute the code that actually throwing an exception. So how to do that? We decided to pick some popular API like query selector all, or you can pick, I don't know, get element by ID or something that most likely Phantom.js script would execute in the web page context, and just overload that function. And what it does, it throws that exception, we check the stack trace for the presence of Phantom.js, and if it turns out it's Phantom.js, then query selector all can do something stupid, like return HTML element instead of the current matching element of the page. In the else clause, we'll just call original query selector all if the execution environment it doesn't look like Phantom. So it's pretty yeah, you cannot call it detection already anymore. You can call it pretty much, I don't know, the Phantom.js functionality disruption or something like that. Yeah, another common scenario is having same origin policy turned off in Phantom.js, because lots of third-party tools that are using Phantom.js for the network layer, like instead of curl, because Phantom.js evaluates JavaScript and things like that, they started using Phantom.js, but they don't really care about same origin policies. So they even either hardcode web security equals false argument on the line where they launch Phantom.js, or they recommend you to launch Phantom.js with same origin policy off. It's quite dangerous because if you know the file path of the file that you want to access, it'd be actually as easy as something like this. Without same origin policy, it will be able to actually read the file using XML HTTP request. And since we, as I showed, Phantom.js also puts the full path of the file it actually puts full path of the file that throws a stack trace, or that generates the stack trace. It will be possible to actually steal the Phantom.js script from the attacker who visits your website using exact the same script. And yeah, another point is me as a detector of malicious Phantom.js, you can always randomize things, like randomize the APIs that you are messing with, as in the previous example where we throw that, where we detect the stack trace. Like, I don't know, on first request you can overload query selector all, on second one you can overload any other API that possibly will be executed by Phantom.js, in Phantom.js, by Phantom.js script. And or like obfuscate the code. It'd be pretty hard for the attacker to figure out what's happening and to take countermeasure, to apply some countermeasures against it.
So to wrap up, there are several things you need to worry about. If you don't need Phantom.js or any full-blown browser engine, for example, if your task can be finished by just a curl script and Python, then you probably should not use them. And second one, you should definitely not run Phantom.js with web security false, because it can read any file on your file system if you have the access. If you run root, actually it can like steal your etc/shadow file and send back to some remote server. You're going to be doomed. And so you should avoid opening any arbitrary page from the internet. Well, I guess everybody should take that. Not only Phantom.js, okay. So no root word, you just use change root. You should create a child process for every page, because a page will show that a page can be very easily crashed. The Phantom.js process can be very easily crashed by a page. And then if security is a requirement, then you should probably try some other alternatives. Say, use
use Chrome controlled with Selenium, because Chrome has much more security
yes.
implemented.
Yeah. So the other side, for the web administrators, you should try to say user agent. To spoof a user agent is hard, but to detect the user agent is also hard. If you don't want to detect the user agent, you should try to save it. It's hard. Yeah. Second one, if you really want to stop the attack from the Phantom.js, to spoof it is actually a good, turn out to be a very effective way, because the other part will try to bail out when you try to sniff it. So a little bit technical will be okay. So we mentioned a lot of different ways to detect it. You can combine them, and you can reject known unwanted user agent. Good start will be 5G blacklist 2013. I think they have
I don't know.
this year. No. So then something like that.
Yeah, and just to really wrap up. So we gathered working examples in this repository. It's like really working. You can really copy a piece of JavaScript into your page and you'll start and implement some kind of reporting, some kind of feedback back to your server, and maybe you'll start getting reports of Phantom.js visitors of your website. And this repository covers probably more use cases that we went over in the slides. Yeah. Like, I don't know, you can look at the screen size and lots of other things. And we're actually implementing them in the examples. And we'll see if I can switch to my console. Just to show you. Probably. If I... What?
No, the command line is.
Oh, yeah.
Like
for example,
remove the clear. Remove the clear.
Okay, I can clear.
Remove the clear.
Oh, remove the clear.
Yeah. There's a clear over there.
Yeah, I don't see the same screen. So, yeah, another way of abusing Phantom.js, but we didn't put it in our repo, is to just to search for already patched WebKit vulnerabilities. And most likely they would work on Phantom.js, because if it's old Phantom.js, then you can pick, I don't know, even like 4-year-old WebKit vulnerability exploit, and it probably would work. And if you are abusing Phantom 2, which is not even released yet, then you probably can pick something fresher. And this one is based on array join implementation in older Phantoms, or in older WebKits. It's pretty reliable arbitrary code execution technique. It will just take some time probably to.
So there is a function inside the JavaScript engine called a string join. It joins strings, but it failed to check whether the length of the string actually overflows. It will actually have a mem copy with negative length, which
I
is
have crash report open here.
Yeah.
Because it might take like, I don't know, 3 minutes. But this one is like very reliable exploitation technique. It happens in memmove. And yeah, if you're really desperate and want to own somebody's machine who runs Phantom.js and visits your website, it's pretty reliable technique to own the actual operating system if he runs as root. Let's see if the demo crashed. Anyway, let's go back to the slides. Yeah, here are some references that we used in our slides, and that's pretty much it.
Yep, thank you.
Our Twitters.
Any questions?
So I know that Phantom has some issues with 302s. Have you guys used that for detection?
302.
Yeah, an issue in redirect.
Well, I know about one issue in Phantom.js around 302. Like if I know that Phantom will apply same origin policy check for XHR, like for XHR, but if for XML HTTP request, but if response to that XML HTTP request is 302 to a local file, it's a way to bypass same origin policy and read the local file. I think it is. It's coming from Qt network stack. It's not like Phantom implements anything around it, but I think there's a patch for that.
So we actually tried it. We make a reflection server that always reflects a file on the attacker's machine, and it didn't work if you have web security to
And
shoot.
yeah, now that will only work if you disable web security.
Not necessarily as an attack, but more as a prevention technique. Because I know for Qt, it's not happy about following the redirect orders and the browser to the next page. So to bypass some of that, at least as an initial stop.
We are not really aware of.
We didn't observe that.
Yeah.
Thank you. Any questions? Okay. Thanks, everybody.
Thank you.